The cumulative relative frequency graph below shows the ages of players in a very popular adult tennis league. What is the best estimate of the percentile rank of a player who is 50 years old? So it's asking us for the percentile rank of this player who's 50 years old. And these graphs, called cumulative relative frequency graphs, what they do is they show us what percent of data is at or below a given point in the data set. And that's pretty useful because that is the same thing as a percentile. So this axis right here, cumulative relative frequency, it's kind of hard to say, that gives us the percentile rank of data points in this set. So this player who's 50 years old, if I start there on the x-axis and trace up to hit the graph, and then over, I can get their percentile rank. So it seems like this player is about 0.9 in terms of cumulative relative frequency. So 0.9 relates to the 90th percentile, so that must be their percentile rank. Let's try another one here. So this problem deals with the same data in the same graph, but now it asks us, what is the best estimate of the median age? And that might not be apparent right away from this graph what the median is. So we need to think about median in terms of cumulative relative frequency. And we know that the median is halfway, or the middle point in a data set, where half the data is below the median and half the data is above the median. So if I had the players lined up by age, let's say, and there might be more players than this, but there might be a certain number of players below the median and a certain number of players above the median, but we know that it has to be the same on both sides. So the cumulative relative frequency of the median needs to be about 50% because there's 50% of data below it. So let's find the cumulative relative frequency over here that relates to 50th percentile. That would be at 0.5. So if I trace over from 0.5, we get to about here, and then I'll trace down, and it looks like we're about 43. So it seems like that's the median age. If we check the other answers, we can see that they're not close to the 50th percentile. For example, 41 years old, we're getting in at about the 30th percentile here, so that can't be it. And then if we try another choice here, like 45 years old, tracing up from 45 years old puts you at about the 75th percentile. So that can't be it either. So it seems like our answer has to be it. Let's do one more. Again, it's the same data in the same set, same graph, and it asks us what is the best estimate of the interquartile range of the ages. So interquartile range, just for a quick review, interquartile range is Q3 minus Q1. The third quartile, subtract the first quartile. Now here, again, we got to think of it as cumulative relative frequency. The third quartile is 3/4 of the way into the data set, so it must have 75% of data beneath it. So we need to think of Q3 as the 75th percentile. Similarly with Q1, that's 1/4 of the way into the data set, so we need to think of that as the 25th percentile. So this formula for IQR we can think of as the 75th percentile minus the 25th percentile. So let's go to the cumulative relative frequencies and find where the 75th and the 25th percentiles are. The 75th percentile, let's see, halfway between 0.6 and 0.8. Here's 0.7, so the 75th percentile will be right about here. And it says estimate, so we don't have to be super precise. And it seems like we're getting 45 for the 75th percentile. And when we find the 25th percentile, let's see, 0.3 is halfway between 0.2 and 0.4. So 0.25, the 25th percentile must be right around here. And when we trace over and down, it seems like Q1 is close to 40. So our IQR, it might not be exact, but it seems like our IQR is about 5 years. So this must be the right answer here.